Okay, so this video is going to be a video over similar figures and scale drawings. And similar figures are figures that are the same shape but different sizes. The corresponding angles are congruent or the same or equal, and the ratios of their corresponding sides are equivalent. That ratio is called the scale factor. So basically on similar figures, the sides are going to be proportional. So let's do an example here. Rectangle LMNO is similar to rectangle PQRS. And if you notice that the L and the P are going to be corresponding, the M and the Q are corresponding, the N and the R are corresponding, and the O and the S are corresponding. And then it wants you to solve for the missing dimension, which is actually side ON. Now, the easiest way for me to think about similar figures is that they're proportional. So what I always do is I always just think of my figures as one big proportion. So now I can say 5 over x is equal to 30 over 24. And I have to make sure that when I do my proportion that it's corresponding. You notice 5 is the top, x is the side. 30 is the top, 24 is the side. Top side, top side. Very good. Then you think about, okay, what's the relationship? What am I doing to 5 to get to 30? Times by 6. So what is x if I multiply it by 6 to get to 24? X would have to be 4. And when we have that relationship, that 6, meaning it's going to be 6 times bigger, going from rectangle LMO to rectangle PQRS, 6 is what we call the scale factor, because that's how it's related. Going from the small one to the large one, you would multiply by 6, and then going from the large one to the small one, you would divide by 6. So let's do another example. A little bit more challenging here. Trapezoid ABCD is similar to trapezoid ABFE, and they want you to solve for x. So on problems like these, they get a little tricky because it's like you have a little trapezoid sitting on top of a big trapezoid. So I always tell my students to redraw it. And it doesn't have to be pretty, but just to redraw it. So this big one is ABCD, and this one is ABFE. And then I just put the measurements. Well, B to F is 4, and then EF is 5, and DC is 15. And it wants you to solve for x. Well, I know if I'm going to have x, I'm going to need to solve for this large side, which is right here. So I'm going to set it up using proportions because the sides are proportional. And I'm going to think about my proportion. What over 15 is 4 over 5? Okay, so now I think they have to be proportional, so what am I doing to 5 to get to 15? Multiplying by 3. So I have to keep that relationship to the top. 4 times 3 would be 12. Now, when they're related by 3, that's your scale factor. Now, the entire side from B to C is 12. Now that's not x. X is from F to C. So if we know the whole thing is 12 and we know this piece right here is 4, then this piece right here would have to be 8. So x would be 8. Okay, another example. The height of a cylinder A is 20 inches and has a radius of 3 inches. Cylinder B is similar to cylinder A and has a height of 4 inches. What is the radius of cylinder B? So here, let's draw our cylinders. Okay, that's going to be cylinder A. The height is 20 inches and the radius is 3. And here's B. And it's similar, it says a height of 4 inches, so B is much smaller. What's the radius? So we need to know, what is that radius? So here, again, it's like a big proportion. Okay, 3 over 20, so the radius over the height, 3 over 20, would be equal to what radius over a height of 4? So find that relationship. If I go from 20 to 4, I'd be dividing by 5. So I got to take 3 in, divided by 5. Okay, 5 will not go into 3, but 5 will go into 36 times. So your radius would be 6/10 inches. Okay, and we will continue working on this in class. Don't think that just because I did 3 examples, I expect you to be, proficient or advanced in this area. So we're going to continue working on it. Now let's talk about scale drawings. Scale drawings are used to represent objects that are too large or too small, drawn or built at actual size. The scale gives the ratio that compares the measurements of the drawing or model to the measurement of the real object. So for example, a scale drawing is like when they want to make a new kind of car, they're going to draw it out on paper. If they want to make new Jordans, they're going to draw it out on paper before they actually make the shoe. So here's an example. Miss Gardner wants to run a billboard and put a message on it. See my message? Math is cool. She's using the scale 5 inches equals 20 feet. What's the length of the billboard? So this is my drawing on paper, and it's 3 inches by 7 inches. So my scale is 5 inches is equal to 20 feet. So this must be the paper, 5 inches, and the billboard must be the 20 feet. So on my paper, let's call this the length. The length on paper is 3 inches. So I need to figure out how much would that be on the billboard. So let's say paper over, I'm going to use BB for billboard, would be 5 inches on the paper to 20 feet on the billboard. Now, you're looking here and you're like, whoa, what's the relationship between 3 and 5? That can get kind of tricky. Well, you don't always have to look from left to right and right to left. You can also look up and down, or this is like the horizontal relationship. You can also look for a vertical relationship. For example, what am I doing? What's the relationship between 5 and 20? Well, I'm multiplying by 4. I can also do that here. And then 3 times 4 would be 12. So if it's 5 inches on the paper, it's 20 feet on the billboard. If it's 3 inches on the paper, it must be 12 feet on the billboard. So the length on the billboard would be 12 feet. And let's do the width. The width would be 7 inches on paper. Okay, and we know that 5 inches on paper would be 20 feet on the billboard. So how many feet is it going to be on the billboard for the width? Once again, 5 and 7, that horizontal relationship's not looking too pretty, but I do notice 5 and 20 again. It's a nice vertical relationship. 4 times, so 7 times 4 would be 28 feet. So 7 inches on my paper scale drawing would be 28 feet in real life on the billboard. Alright, sorry that was kind of long, but it's a lot of information to cover, and I just want to go over one more thing before we wrap it up. So on similar figures, triangle ABC, triangle DEF. Basically, if they're similar, angle A is going to correspond to angle D. Okay, and you can see A and D are the first letters, A and D, so they should be equal. For this is 30 degrees, this is 30 degrees. Angle B corresponds to angle E, and you see it's the second letter in the name. If they are both 40, they'd both be 40. Angle C and angle F correspond to each other, they're going to be congruent. And this is only if it says these are similar shapes or figures. AB would correspond to DE, and that's AB, DE. BC would correspond to EF, and you see BC, EF. AC, DF. So I just wanted to make sure that I kind of went over that once again. And that is all.